Aberration. In astronomy, aberration is the difference between the actual and apparent location of a celestial object, typically a star. The usual analogy used to illustrate aberration is standing still under the rain versus running with your umbrella against the rain. When running against raindrops falling straight down, they appear to be striking the umbrella at an angle. Let's simulate aberration under the rope model of light. We imagine a torquing electromagnetic rope interconnecting an atom of the sun and an atom in your eye. What happens when the Earth carries you around with respect to the sun? Despite the enormous speed in which the torsion signal propagates along the electromagnetic rope, it nevertheless takes about 8 minutes for this three-dimensional disturbance, if that's how we decide to refer to it, to reach the Earth, simply because the sun is so far away. Here we simulate the trajectory of this pulse imparted on the rope by the atom in the sun with a ball. You can readily understand now why the mathematical physicists confuse this propagating segment of the rope with a discrete particle which they call photon. The 3D wave generated in an atom of the sun, and which we call light, can never get lost, because it can only propagate along an invisible, intangible physical medium that connects that atom to the one in your eye.